Chapter 5: Python Operators and Expressions. Learning Objectives. After studying this chapter, you will be able to understand different types of operators used in Python. Discuss expression. An operator is a symbol that instructs the computer to carry out specific logical or mathematical operations. Operators are the building blocks that have the ability to change the operand values. The operators available in Python language are extensive. Operands are the values or variables on which the operators do some work. Definition: operator is a symbol that performs an operation on one or more operands. An operand is a variable or a value on which you perform the operation. Python provides various types of operators that do mathematical and logical computations. 1. Unary operators. Those operators that require one operand to operate upon. For example, unary plus, example, a is equal to 2 plus a. Unary minus, example, a is equal to minus 4 minus a. 2. Binary operators. Those operators that require two operands to operate upon. Following are some binary operators. A. Arithmetic operators. B. Comparison operators. C. Assignment operators. D. Logical operators. E. Bitwise operators. F. Special operators. G. Membership operators. H. Identity operators. Arithmetic operators. The basic arithmetic operators are all available in the Python language. These operators are used to perform math operations including addition, subtraction, multiplication, division, and modulo, as their name implies. In Table 5.1, the arithmetic operators are listed together with a brief discussion and an illustration of each. The use of all arithmetic operators is demonstrated in Program 5.1. Operator, description, syntax. Addition. Add two operands, x plus y. Subtraction. Subtract two operands, x minus y. Multiplication. Multiply two operands, x multiply by y. Division float divides the first operand by the second, x divided by y. Division floor divides the first operand by the second, x division floor y. Modulus returns the remainder when first operand is divided by the second, x modulus y. Power returns first raised to power second, x raised to power y. No more. Operations on variables and values are carried out using operators. Program 5.1. Illustration of arithmetic operators. Output. Comparison operators. These operators are also known as relational operators because it compares two values and returns the Boolean value as true or false. In Table 5.2, the comparison operators are listed. The usage of comparison operators is demonstrated in the program 5.2. Operator, name, example. Equal, x equal y. Not equal, x not equal to y. Greater than, x greater than y. Less than, x less than y. Greater than or equal to, x greater than or equal to y. Less than or equal to, x less than or equal to y. Smart tip. To compare two values, comparison operators are utilized. Program 5.2. Illustration of comparison operators. Output. Assignment operators. The assignment operators are used to assign values of the right expression to the left operand. They perform simple arithmetic operations and are also known as augmented operators. The assignment statement examples are shown in program 5.3 below. Smart tip. Assignment operators are used to assign values to variables. Program 5.3 Illustration of assignment operators. Output 10 greater than. Table 5.3 lists the assignment operators and compound operators. Operator, example, save as, equals to, x equal to 5, x equal to 5, plus equal, x plus equal to 3, x is equal to x plus 3, minus equal to, x minus equal to 3, x is equal to x minus 3, multiply equal to, x multiply equal to 3, x is equal to x multiply by 3. Divide equal to, x divided equal to 3, x is equal to x divided by 3. Modulus equal to, x modulus equal to 3, x is equal to modulus 3. Divided equal to, x divided equal to 3, x is equal to x divided by 3. Raised to the power equal to, x raised to the power equal to 3, x is equal to x raised to the power 3. And equal to, x and equal to 3, x is equal to x and 3. Vertical bar equal to, x vertical bar equal to 3, x is equal to x vertical bar 3. XOR equal to, x XOR equal to 3, x is equal to x XOR 3. Right shift equal to, x right shift equal to 3, x is equal to x right shift 3. Left shift equal to, x left shift equal to 3, x is equal to x left shift 3. Table 5.3 List of assignment operators. The usage of assignment operators is demonstrated in program 5.4, where the shorthand operator is used with the arithmetic operators equal to, plus, multiply, divide, and modulus. Smart tip. The right side operand and left side operand are added using the add and assign operator, and the result is then assigned to the left operand. Program 5.4 Illustration of assignment and shorthand operators. Output. Logical operators. Logical operators are used to combining one or more conditions or expressions. The various logical operators are unary not and binary or, and. While using logical operators, the expression always results in true or false, that is, 1 or 0, depending upon the combination of logical operators used. In Table 5.4, the logical operators are listed. Operator, description, example. And returns true if both statements are true. X is less than 5 and x is less than 10. Or returns true if one of the statement is true. X is less than 5 or x is less than 4. Not reverse the result and returns false if the result is true. Not x is less than 5 and x is less than 10. Table 5.4 List of logical operators. The application of logical operators is demonstrated in program 5.5. Only the expressions that compute true results are coded in the program. Program 5.5 Illustration of logical operators. Output. Bitwise operators. Bitwise operators work on bits and performs bit-by-bit operation. Assume if A is equal to 60 and B is equal to 13. Now, in binary format, they will be as follows. A is equal to 00111100. B is equal to 00001101. A and B is equal to 00001100. A or B is equal to 00111101. A XOR B is equal to 0011 0001. Tilde A is equal to 11000011. There are following bitwise operators supported by Python language. Operator, description, example. Binary AND. Operator copies a bit to the result if it exists in both operands. A and B means 00001100. Binary OR. It copies a bit if it exists in either operand. A or B is equal to 61 means 00111101. Binary XOR. It copies the bit if it is set in one operand but not both. A XOR B is equal to 49 means 00110001. Binary ones complement. It is unary and has the effect of flipping bits. Ones complement A is equal to minus 61 means 11000011 in 2's complement form due to a signed binary number. Binary left shift. The left operand's value is moved left by the number of bits specified by the right operand. A left shift 2 is equal to 240 means 11110000. Binary right shift. The left operand value is moved right by the number of bits specified by the right operand. A right shift 2 is equal to 15 means 00001111. Membership operator. Python's membership operators test for membership in a sequence such as strings, lists, or tuples. There are two membership operators. Operator, description, example. In evaluates to true if it finds a variable in the specified sequence and false otherwise. X in Y here in results in A1 if X is a member of sequence Y. Not in evaluates to true if it does not find a variable in the specified sequence and false otherwise. X not in Y results in 1 if X is not a member of sequence Y. Identity operators. Identity operators compare the memory locations of two objects. There are two identity operators explained below. Operator, description, example. Is evaluates to true if the variable on either side of the operator point to the same object and false otherwise. X is Y. Here is results in 1 if ID X equals ID Y. Is not evaluates to false if the variable on either side of the operator point to the same object and true otherwise. X is not Y. Here is not results in Y if ID X is not equal to ID Y. Program 5.7 Illustration of Identity Operators. Output. Expressions. Any computer language's fundamental statement is made up of expressions. The operand and the operators are the two fundamental components that make up an expression. The Python language has a wide variety of operators, as was previously mentioned. In the Python programming language, operators are symbols that can be used for both arithmetic calculations like addition, subtraction, multiplication, and division, as well as logical calculations. Expressions are created by combining variables, constants, and Python operators in order to conduct arithmetic and logical calculations on an expression or operand. Operators require more than one operand. The operator precedence rules, which specify the order in which an expression's operators are evaluated, are used to evaluate the expressions. Let's recall. An operator is a symbol that instructs the computer to carry out specific logical or mathematical operations. The basic arithmetic operators are all available in the Python language. These operators are used to perform math operations, including addition, subtraction, multiplication, division, and modulo, as their name implies. The relationship between expressions or operands influences some programming decisions in Python. In Python, the special symbol is referred to as an assignment operator. The bit operations are carried out on the operands of the bitwise operators, which are assumed to be strings of bits. The identity operator and the membership operator are two examples of the specific types of operators available in the Python language. Identity operators are used to comparing the memory locations of two objects. Python membership operators check a sequence's membership.